एपिसोड अभी थोड़ी देर में शुरू होगा। बेसिकली एक अफिलिएट मैसेज। क्रियो एक कंपनी है, मैं काफ़ी टाइम से फॉलो कर रहा हूँ। रिसेंटली मैंने एक माइक लिया था इनका, काफ़ी अच्छी बिल्ड क्वालिटी है और ऑडियो भी ठीक आती है। इसमें थोड़ी फाइन ट्यूनिंग मेरे को करनी पड़ेगी, बट मेटल बिल्ड है तो काफ़ी सही होता है क्वालिटी एंड ऑल। इसमें ये इससे काफ़ी सारे प्रोडक्ट्स हैं, आपका कंटेंट क्रिएटर्स के लिए हो चाहे गेमिंग के लिए हो, आप देख सकते हो वेबसाइट। एंड प्राइस भी काफ़ी फेयर है, मतलब मेरे को ऐसा कुछ ज़्यादा महंगा नहीं लगा। ये इनके मैकेनिकल कीबोर्ड्स हैं गेमिंग के लिए। ये इनकी चेयर्स हैं, काफ़ी कंफर्टेबल हैं। एंड इन्होंने अभी एक स्क्रीन रिलीज़ किया ऑब्सिडियन 27 इंच का। मैं भी 27 इंच यूज़ करता हूँ। माउसेस भी नहीं काफ़ी अच्छे हैं। तो बेसिकली इफ़ यू वांट टू बाय समथिंग और एक्सप्लोर, यू कैन यूज़ माय लिंक इन द डिस्क्रिप्शन, एंड मैं वो लिंक भी लगा दूँगा एंड अपना एक कूपन कोड भी लगा दूँगा। तो अगर अच्छा लगे तो बाय कर लेना। एनीवेज़, अपना एपिसोड शुरू करते हैं इन 3, 2, 1। Namaste everyone. This is not a podcast, but a Vārtalāap, where it's all about curiosity. And I'm your host, Yash Tomar.
So, yet another episode of Vārtalāap, episode number 91st. And we had some technical glitches, so we are releasing this one right now. And we are still strong for our Diwali target of 100 episodes before it. So, in this episode, I have with me Shrimanji, and we'll talk about manufacturing in this particular episode. So let's start, Shreman. We'll go through your journey basically in the starting. For the starting, like what made you go in this particular field?
Namaste everyone. This is Srimannarayana. So I chose the field of manufacturing because I was interested in knowing how things work and how are things made from my childhood. So that's where the journey came into taking mechanical engineering, and it's an interesting journey of I represented India in a competition called as World Skills, which is a global skill Olympics. So this journey had a lot of influence in my life, and also it didn't take place directly. It was with the help of a lot of people, mentors, friends, and my family. So let's go from the beginning. So in my engineering, we are basically going through our regular studies, and there's a few hobby clubs and engineering clubs. Then I joined one club called as KREO Racing, which was regarding student Formula racing. There is something called as you know, there is Formula One. It's a
Yeah.
motorsporting event, international motorsporting event. Similarly, there is something called as Formula Student. So they have also have an Indian edition of it, apart from many multinational areas such as Europe, Asia Pacific, and America. So we were one of the teams from India, one of the teams competing from IITs with one of the prominent competitors, and we ranked around 13. So interesting journey to practically actually implement the theoretical knowledge and check how the difference between validation is and how to revalidate things. That's a very important thing, not only for an engineering aspect, but also life. Like you can have a lot of experiences or someone saying something, but without experiencing that, you cannot really deeply understand what is it. So that's what, from a theoretical classroom background, when we came into practical environment, it made our fundamentals more stronger, made us think more deeper how things are correlated. So that was an interesting journey. Later on, I was mostly focused on design and manufacturing. So that's where in my final year of engineering, it was an interesting twist. I got an opportunity to represent my state, Andhra Pradesh, for this regional level of selection for IndiaSkills, which is a preliminary round of selections for the international event World Skills. So that's where I had a chance like to represent Andhra Pradesh or go to my campus placements. It was like a tricky question. I got a call during a break period in my final year, and they were like, "Are you ready to travel to Bangalore? This Toyota Biddi plant for your next level of competition training arranged by the state government." Like in the similar next coming weeks, there are like prominent mechanical companies coming for interviews. Like a lot of people, my seniors and many people kind of opposed it. Like it's just a competition, it won't have that much effect in your life rather than go for the interviews. I always had a perspective like was not like someone trained me, but I was not always onto the thing like go with the flow. I was like always ready to experiment or take the risk in order to experience something new. I'm like, okay, what if I miss the interviews in the next week? There's still 6 more months, one more semester left. Like I took a kind of opinion and I finally decided and I left the campus placements and I went for the competition. Fortunately, I cleared that round and within 1 week there was the regional round. That was also cleared. And that 1 month experience in Toyota was really fascinating. The people, how they actually work in the industry and the mindset of the people in academia, not prominent academic institutes, but I came from a decent private institute, I can say. So people were not that focused into extracurricular activities apart from theoretical academia. So these competitions are basically kind of things which are testing your practical experience and how you can perform in a competitive environment with restricted time and options available. That's what actually happens in the real world. So post that, we were again given a training in Toyota. So the next upcoming 2 months, I missed all my campus placement opportunities. So finally, there was some 2 months gap before the national level. So I came back to the college and I found out like since I took a 4 months gap, I was kind of removed out of the campus placement program.
Okay,
And
okay.
also I lacked attendance because it was a 2 months gap. They were like, you are going to be detained, you have to redo the whole semester. So like I represented my state. Finally, we kind of convinced the dean, and the dean gave a special permission, and the HOD approved for attendance related issues. So it was a kind of interesting and also a tense moment. So yeah, after all these things, finally IndiaSkills came into the picture. So I went, represented, got the fourth place. It is a skill called as prototype modeling, where you have been given a production grade engineering drawing. So you have to develop a 3D model in a CAD software. CAD means computer aided design.
Yeah.
Suppose that whatever you have created, you have to redo the drawing from your own design in the system. So finally, that drawing will be given for you to manufacture your own design. The tricky part over here is the original drawing which was given to you will be taken after first 2 rounds. If you messed up your design or the drawing you have recreated, so the whole manufacturing aspect will be done by your own drawing. So you have messed up the whole competition. That's how there were tiny like aspects, but very crucial. So these things happened, and finally there was a situation where again crucial companies were coming. There was national level. They told they'll be taking us to Delhi, where there will be arena for all the 65 skill competitions from 6 industrial sectors. I'll just present my screen to show
Yeah,
what
sure.
these competitions I mean.
Yeah.
Just a moment. Yeah, so this is World Skills. World Skills is a kind of NGO organization. It was established post World War II. The agenda of the
Okay.
competition post World War II was in order to hire skilled people into the industry for reconstructing and developing all the European nations. So post that, it has become a European skill competition after 1 or 2 decades, and laterally it spread out throughout the world. And currently there are 65 skill competitions available. The best part about all these competitions is there is no restriction with terms of language barrier or your educational qualification. Clearly defines your skill.
Okay,
So
purely
basically,
skill, right?
yeah, purely skill based. So this is where I had the opportunity to represent Team India in the World Skills 2022 conglomeration. It's also interesting Germany, which was supposed to be happening in Shanghai 2021, but due to COVID, it was kind of preponed. and it was held in 15 different countries in 2 months span in 2022. It was a kind of decentralized, but I still had the opportunity to represent India in Germany, and it's a very interesting aspect to know how people exactly work in different cultures and different ecosystems. For
Yeah.
example, Germans, they are fully focused on what they want to do. They clock in, clock out in perfect timings. I was like, there were Chinese competitors and Japanese competitors. It was a kind of a different mindset I have observed over there. Most of the countries, they select their competitors within kind of 1 year before the actual event. But whereas coming to China, they are actually World Skills is actually a biannual event, so it happens 2 years once. So China used to select their competitors 6 years in advance,
6
and you select
years.
them, and yeah, it was crazy. I was like thinking, how are they able to outperform us so quickly? I got around 6 months
Okay.
of training, and then it was around 1 year of selection rounds, 8 selection rounds with 6 months of training. Competitor was selected 6 years. It was a totally different mindset or level of preparation they had, but that's not an excuse. So
Yeah,
that's where
definitely. We are
so
back.
in the contrary, the Chinese used to select their competitors 6 years earlier before the competition. So that's how serious they were into any arena where they had to compete. For example, the sports Olympics or World Skills or Skill Olympics, they didn't lag anywhere. This also reflects how the world of manufacturing goes around. Most of the things you see, it's made in China. There's a particular reason for that. There's a standardization, there's a quality of work output which is given for a considerate amount of cost factor. That's why most of the world goes over there. So even nowadays, there are schemes such as Atmanirbhar Bharat and all, which are trying to promote a lot of things which can be done indigenously. So that's how one of the things happened. Like Intech Creative Solutions, one of the previous companies which I worked for a couple of years, where there was India's first metal powder 3D printing based OEM. OEM
Okay.
meaning original equipment manufacturer. It was an interesting journey also. So, such as like this, you can see there are n number of startups, but lot of startups which come out of India are mostly kind of things that want to replicate an existing idea and try to scale it up.
Yeah.
Innovation is happening in a way, but not happening in a groundbreaking way where it's happening in Europe, China, US, or the other parts of Asia. One of these reasons is support. Because when I was trying to represent for these competitions, I never got any monetary support. I also had to literally take permissions or give additional requests so that I was not debarred for a whole semester.
Yeah.
So similar kind of things actually resist people to partake into other endeavors in life. If such kind of things like a basic level requirements can be fulfilled, so people also can come forward to represent themselves in a bigger platforms to create better things. Instead of a competitive environment, it could be collective collaboration.
Yeah.
That's what teamwork is, right? But unfortunately, in most of our education journey, the aspect of teamwork is almost nil. There's always competition. But whenever you come to a career or real life, that's where people expect you to collaborate and do stuff. That's why if collaboration can be a thing from the beginning steps of the education system, I guess people would build better things together because it's better to have multiple minds working on a specific problem rather than one mind alone. Because multiple perspectives given a lot of good valid inputs. So post this, as I have earlier mentioned, there are 65 skills from construction, manufacturing, IT, social and healthcare,
Yeah.
creative arts and fashion, and also so forth. Certain industries like logistics, transportation, and maintenance. So finally, this was Team India, my batch, whom I had the opportunity to literally meet wonderful 52 people from 52 skills all over the India, share their views, perspectives. Finally, I was trained in NTTF Bangalore. NTTF is a prominent tool room training center for manufacturing skills such as injection molding, CNC machining, designing, and other things. And Mr. Prashant was my mentor who trained me for this particular competition. I had a lot of things to learn from him, and I have a lot of gratitude to that man. Still in good connections with him, and the journey goes on. And
Yeah,
this
I
is a
mean,
kind of a glimpse.
yeah,
Yeah,
it is
I'll just
an
show you.
inspiring journey. Yeah, you can show me. Meanwhile, I had a question to ask you. Like, the CAD software
Yeah,
is a type
definitely.
of a software, right? And the Fusion 360 is also part of it.
Yeah, CAD is a tool aid which helps you to design things virtually. It's like as the name suggests, computer aided designing.
Yeah,
So Fusion 360 is one of the recent emerging softwares from Autodesk. So we have around 5 to 6 prominent players in the market. Like you have PTC KREO, who has KREO OnShape. Then you have Dassault Systems, like SolidWorks and CATIA. Then you have Siemens, which has NX. Then Autodesk with AutoCAD, Fusion,
yeah,
Inventor, and multiple other softwares. So
yeah.
each
I mean,
software has its
definitely.
own unique, yeah, advantages, and mostly softwares are selected based upon the feature requirements which are there for the specific industries, or in certain cases, the price points, the licensing, and the collaboration that the software provider is giving to the company.
Okay, because I primarily use Fusion 360 for like hobby 3D designing and all. In I don't remember to
Yeah,
2019 and 2020. So I mean it was a very big software for me personally also, and a smaller version of that was maybe Tinkercad for me, if you know what I mean,
yeah,
because
Tinkercad. Yes, it was also
it
from
is
Autodesk.
a 3D development software for basically kids. So like both of them were very good, and then I with this I got to know about the 3D printing and all the technology. And I guess 3D printing was I was doing I mean designing and getting to know about this in my 10th, so basically 2018. So as like time
Oh,
moved on,
interesting.
I couldn't continue it and all, but yeah, I have done these things also. Yeah.
That's interesting. 3D printing actually, it's a desktop 3D printers are affordable and easy to operate, and they give you the opportunity to embodiment your imagination or creation into a physical object. So that's an
Yeah.
interesting technology.
Yeah, definitely. And like you were talking about China and the 6 years, I think they are right now not really playing for this still competition. They are just using this as an excuse for developing students for their lifetime, because 6 years is a very big
Definitely.
time.
Yeah.
And like engineering degree is only, I mean, 4 years. And
Yeah.
many people don't do much in this. And I mean, skills and that to 6 years would definitely like make the whole nation very productive.
I too felt a certain thing. There are like certain skills which require creativity or productivity out of mental power. I meant to say
Yeah,
thinking to create new things. And there are certain skill sets which are repetitive works. Once you learn it and know how the process works, such skills they try to improve the efficiency rather than improving the process. In a way, it is
yeah,
not process orientedly productive, but in terms of efficiency for the existing process to physically have an embodiment in the industry to increase the reduce the lead time of each process is improved. So in a way, I guess people can't learn much from such skills because we are living in an era of automation and AI. it can easily
Yeah.
take over such tasks.
But I mean, learning a skill teaches you to do a thing by your hand and with perfection. So it would be
Yeah,
like a net positive only.
yeah. This is the institute entity of Bangalore where I got trained, and Mr. Prashant was my expert mentor. And this is a small glimpse of what we had in 2022 October in Germany.
I mean, to be honest with you, like I knew
Yeah,
skills are very important since Modi ji started like telling about this and all. And I saw the job market, but like I didn't knew these skill competition do exist also. So I mean,
uh,
that should be like
that,
90% of the youth won't be knowing about this. So maybe we can bring awareness with this episode.
yeah, definitely. Actually, thank you for bringing this point up. I just recollected my 2018 final year journey. Like, one of my mentors told about this competition, and like, you're good in hand skills, manufacturing and all. You just go for it. And as I mentioned, I didn't get a positive feedback from my seniors and co-students. Their perspective is
Okay.
like, its skill is kind of like, apart from the designing, the manufacturing is like ITI or diploma guy's job. You are an engineer. Why are you doing that?
Yeah.
Like, my mindset was different because I grew up in a household in my childhood where I was only with my grandparents, and my grandfather was from a military background.
Okay.
So
Okay.
he made me do a lot of chores. Apart from that, gardening, taking care of regular home repairs, like carpentry work, plumbing work, electrical works, and all. So it was like, for me, it was a regular thing in life. But most of the other people whom I was with, it's like they think that engineering is something which is very
Hope the internet issues resolves, or else
it is a
I'll.
kind of medial job.
Yeah.
Yeah, it's continuing, right? Yeah, okay. Uh, it was already interesting thing. So hence, as I mentioned, I took mechanical engineering. I thought, okay, as I mentioned, I went for it, took a shot. In the
Yeah.
long term, after 5 years, things went for a positive effect compared to the initial progressions in 2018. So what happened after 2018? I didn't clear the nationals. Was like, as I mentioned, I nearly skipped 6 months of my campus placements. All the major mechanical companies went out. There are only a few IT companies and local workshops who give manufacturing services. Like, the salaries were like literally 10K, 15K per month. I was like, I thought, okay, I'll try to do something else rather than go and work over there and waste my time. And after May, I graduated in 2019. Literally till July, I was like staying at home, preparing things, trying out interviews. Like, most of the people were like, if you didn't clear, why didn't you clear any of your what is this campus placements? Like, I couldn't
Yeah.
attend. Like, then why did you do engineering? I had certain questions like that. Like, I never got discouraged. Fortunately, my father and grandfather never discouraged anything. They used to say only two things: own your decision. If they knew what it was, they told, okay, they used to explain, or they used to say, we are not aware of it. But they never told, keep quiet, shut your mouth, and do what is told.
Yeah.
Thought of doing things by my own. So after that, in I guess around August, I got a call from one of the institutes, Bannaraman Institute from Tamil Nadu. So they were like, we've seen your participation in IndiaSkills. Are you interested to join us for training our students for the upcoming event? I was like, okay, let's take a chance. whether anyhow I'm sitting at home, not having a job. These guys gave some opportunity. I like skills. Let's try skill training. And so I took the opportunity, but the catch was like they were only paying around 10K per month. And final thing was they told they'll take care of accommodation and food. I'm like, okay, let's try it. So that's where I spent nearly 3.5 years of my life till the end of 2022. And as I mentioned, this skill competition never had something such as educational qualification or language barrier. They also have opportunity, like option to send a translator along with the competitor to the international event. So the only limitation or eligibility criteria is age limit. So most of the skills have the age limit of 22 years at the year of the World Skills competitions, and certain skills 25 years.
Okay.
So prototype modeling was 22 years, and I participated. I came out, and I was 23, or I'll be 24 in the next skill competition. That was in 2021. So none of the skills which had the age bar of 25, I was well versed in that. But I was like, okay, let's go. Then COVID struck. Then in 2020, I guess 2021, 2021 August, there was a new launch of new set of skills in which additive manufacturing was there. And one of the lab in charges where I was working, Mr. Prakash, Dr. E. Prakash, he was into additive manufacturing or 3D printing. That's where he also suggested me to go for a master's program. There was actually no intended master's attempt by me, but as he persuaded me, I took for the master's program, got to additive manufacturing, and the kind of end of 2021, there's a chance to again go through another attempt. Like, but over here, Bannariyaman, they supported in the whole training process, travel, accommodation, reimbursements, and all. So it was kind of even helpful. The prime, which I was earlier saying about the basic necessities, so that you can go for the next attempt. That was taken care by Bannariyaman, which is really helpful, and it also played a very crucial role for me to finally representing India. It was around 1 year of selection process, and we had in 2022 January the national skill competition in Delhi. So it was a very tense moment. Finally, I cleared that too. I got the gold medal, and we had a training program in this entity of Bangalore, which I was mentioning earlier. It was a 6 months training program where me and the silver medalist, Dhruv Verma from UP, together we trained and compete again for 3 selection rounds in the 6 months period. But collective collaboration, which I was referring earlier, was a thing which I actually picked up in that particular 6 months period, because Dhruv was a very open-minded guy. We actually learned together, shared information. But when the 3 selection rounds were there, we competed. But in the remaining periods, we were in the mindset, right? Any one of us is going to represent India. So we should be prepared fully to our best capability in the limited 6 months of time. If there was a wholly not an open-minded guy, I wouldn't have had a better learning opportunity, which is like a coexisting learning opportunity over here. I was lucky I had that guy over there. And finally, unfortunately, we couldn't make it, and I represented India over there, and that's how it happened. So after coming back, I was thinking like I spent nearly 4.5 years from 2018 to around 2022 year end for this World Skills competition. Because post this competition, again, I didn't get any major job offers. I got a job offer from one of the contacts where I got trained in this 6 months, and I took the chance and I went to Bangalore, where I joined the manufacturing industry in the domain of 3D printing. So what happens over here is basically market value. So IT related sector, you develop a product, and the product can be sold n number of times. There is no cost for replicating the product in most of the cases. So your revenue stream is high, henceforth your market cap is high, and you get better salary pays. Whereas you are coming to the manufacturing industry or any industry where there is a requirement of a physical object to be embodied as a product to be sold. You
Yeah.
have an R&D cost. You require an inventory, a warehouse, a plant, machinery, skilled workforce, management, inflow of money, outflow of money. All planning is required, which takes a lot of money, space, and time requirement and skill effort into it. Even after this whole cycle, you develop a wonderful product, you want to launch it into the market. Still, each time you have to remanufacture it. So that's how the market cap is little bit less. Henceforth, the paychecks we get in the manufacturing industry are less. But still, if you are into niches, like certain particular niches like additive manufacturing or emerging technologies, R&D, still you can really bag wonderful packages similar to the IT industry, even in the manufacturing industry. Plus
Okay.
point in manufacturing industry is the amount of exposure and experience you have. So there are very less openings. So hiring is very kind of less compared to the volumes of the IT industry. So less people are hired, they are retained for a long time. So people are well versed and experienced and in a demand. So if you can establish your footprint into the manufacturing industry, it's a kind of a very safe marketplace, is what I can say, compared to the IT industry. But again, there's a trade-off. Obviously, the paychecks. You have to
Yeah,
decide
definitely.
what you want to do, and you have to carry forward with that. That's how this whole manufacturing journey and everything went on. And post after that, I recently joined Xlogic Labs, which is a Coimbatore-based robotic automation firm for manufacturing with the aid of AI learning.
Yeah,
So this is
but
one of the
before we go,
establishment. Yeah,
yeah, before we talk about that particular company, because we have a lot to talk about it. Uh,
yeah, definitely.
like talking about very basics. How do you explain manufacturing in a line or so, and like also if you can describe the additive manufacturing and other types of it, like
Yeah,
very basic
definitely.
layman. Yeah.
Yeah, yeah. So in a basic sense, you can say manufacturing is a approach to create a product which is useful for the initial purpose of the design. So I'm back, right?
Yeah, you are back now.
Yes. Yeah.
Yeah.
Okay. So basically, manufacturing is a physical embodiment of a solution for a given problem statement. The approach is like you have a real world problem statement to which you have to conceptualize a solution in terms of a design. Then you iteration is a process of refinement from the initial idea to the final idea. Finally, once the final idea is done, you prototype, you refine the prototype, and you go for the manufacturing. Henceforth, you get your solution for the initial problem statement which you had. For example, let's say basic day-to-day things. Maybe you want to dry your clothes. So there's a
Yeah.
lot of wind on the way, so things go off. So you can simply make it with a clip, which is nothing but a wire spool wound into a shape, or you can injection mold and make a plastic clip, or you can use bamboo wood with a metal spring. There are multiple approaches based upon your
Yeah.
requirement. So it's not like the problem statement will only have a single solution. There might be multiple solutions for multiple different requirements of the same problem. So the requirements might be material, structural integrity, cost factors, or longevity or customer requirements. There are multiple factors in which you select a particular approach. So manufacturing is of three basic categories: subtractive manufacturing, formative manufacturing, and the third one, additive manufacturing. So subtractive is basically like you have a bulk of raw material and you use a tool to remove the unnecessary material to get the desired shape. So as you
Okay.
are removing material or subtracting material from the raw material to get the desired outcome, it is henceforth named as subtractive manufacturing. We have multiple types of subtractive. Similarly, formative. Subtractive and formative have a very long history compared to additive, which was an emerging thing in the early 80s. So formative is a way where you have a form or shape into which you pour molten material. So hence it takes the form of the cavity. So that is how it is forming, and formative manufacturing has been named. And similarly, additive, it's a layer by layer process which you add upon material, layer upon layer, to get the desired shape outcome. So I have a small presentation over here to further have a deeper understanding about what is additive manufacturing and the types of additive manufacturing approaches your earlier question.
Yeah, and I guess I with after this presentation we'll talk about
Yeah,
the differences of people's expectations. Like most people want to go engineering, and they choose any
yeah,
stream and then the IT stuff. Yeah.
got it, got it. So basically, what's additive manufacturing in terms of let's go to world skills, as I have already mentioned the normal approach of manufacturing. So you have in 3D printing technologies, you have basically 7 different categories, and out of that, 3 certain categories was used in world skills, followed by 3D scanning, which is a reverse engineering approach to get the surface data, and using that data, you recreate the original CAD. Henceforth, you can manufacture it. This further on will be detailedly described. So rapid prototyping is a method or approach where you can manufacture things in a quick way so that you can iterate it. So 3D printing or additive manufacturing are one of the technologies in rapid prototyping.
Yeah.
So as mentioned earlier, in subtractive manufacturing, you have a chunk of material or the raw material where you remove the unnecessary material to get the desired shape. Henceforth, over here, you have a lot of waste. In certain cases, it can be recycled and repurposed. But coming to subtract additive, it's a layer by layer addition process. Henceforth, you require less material to create
Yeah.
your desired shape. So these are the basic 7 categorizations of additive manufacturing technologies as per the American Society for Testing of Materials. So we'll further go on and have a deep dive about this. So material extrusion, which is a well-known name as fused deposition modeling or FDM, where I guess you also worked with earlier,
Yeah. 3D printing, right?
right? Yeah, 3D printing, FDM. So FDM extrusion means passing through material from a certain shape or cross section, like concrete. You can also do biological implant
Yeah.
scaffolds, tissue culture, chocolate 3D printing, polymer, ceramics, and metal 3D printing.
Clay, right? Yeah.
Yeah. So basically, you have the 3D shape which is sliced up into multiple 2D cross sections of very minimum thickness. Henceforth, the first layer will be the base for the second layer, and the second layer will be the base for the third layer, and the third layer will be the base for the fourth layer. And that's how you approach. You might require support. This technology is in all like
Yeah.
formative and subtractive manufacturing. You can only have solid components. But in 3D printing, you can also create hollow shapes with varying density.
Yeah.
As you have
Yeah.
a print head
Infill.
moving in a infill. That's the best part about additive manufacturing, which can also reduce your weight and improve strength at the same time.
Yeah.
So VAT
I mean, those who
photopolymerization is a
have
kind of yeah,
yeah, those who have done the 3D printing and all would like know all these things on tips.
yeah. So this was the first technology invented in 1986 by Mr. Charles Hughes. In this particular technology, you have a liquid resin, which is called as a photopolymer, which is sensitive to UV light. So
Yeah.
whenever UV light touches the resin, it hardens and transitions from a liquid phase to a solid phase. So VAT basically symbolizes a tank in which the photopolymer is stored in. That's how a layer by layer approach, you can get overall a 3D shape. And you can see this is a 2 mm is a matchstick head, and you can have high resolution parts like this. 500 micron
Yeah.
is literally nearly the size of hair. So very, as you can
Yeah.
see, the representation with respect to the matchstick. So there are multiple subcategories of how you can produce the same thing. Let's not go deep into that. And this is approach where you can use polymer or metal powders to get the final output, which is a three-dimensional solid part. So this is for
I
polymers.
have
To
I
get
have a
that,
question
yeah,
about
yeah,
this the metal powder thing. If you have to like make a hollow metal object, how will we get the
yes.
dust out of it?
So basically, you provide drain holes,
Okay,
minimum
okay, I
two
got it.
drain holes, so that you can put a vacuum and pump air on the other side and drain off all the powder.
Okay, okay, okay. Yeah, I mean I got it.
Uh, this is the technology which I was working in my earlier company, Integrated Solutions from Bangalore. It's a wonderful company and technology, by the way. And this is also one of the cool technologies called as material jetting, where you have an inkjet printer, right? So similarly, you have a material jetting setup where you can actually print multiple different materials or colors in the same single shot. So that's how you can get
Okay,
like flexible bottle cap or a representation of a heart for surgical aids, pre-surgical studies, or super realistic prototypes. There is no leather, wood, and a digital display over here. It's just a polymer model of it for a visual representation for presentations or
yeah,
in
definitely.
detailed iterative studies. So similarly, you have another approach using powders for creating metals, ceramics, polymer multicolor parts, and for casting, which is formative manufacturing base patterns. So this is a hybrid approach called direct energy deposition, where you use metal kind of, it's a welding approach or a deposition approach, where you weld on material, get it, and using again CNC machining, you machine it to the desired shape.
Yeah, I
So the
guess I
advantage over here, yeah,
saw a video of like they were making a boat and like they were using I guess 2-inch thick metal strips.
yeah. So it's hybrid approach. Similarly, it is something called as sheet lamination, where a continuous film is cut and the desired shape is actually glued with the help of adhesives, and the unnecessary desired shape is removed off, which is a support.
Okay, okay.
These are one of the major market players who had given a lot of innovation into the market of 3D printing technology. And it's like it has multiple applications. Like these are biological implants, metallic scaffolds, prostheses, or hyper realistic figurines, prototype or concept things. Similarly, like chocolate 3D printing. And also, you have a cool thing, you can actually give a 4D effect with even 3D printing. So, as multiple material can be printed and fused together in a 3D shape, there are certain materials which react to electricity or heat, which give a effect of movement, which is nothing but the fourth dimension over here. So this is one of the prototyping injection moldings or for educational purposes, fashion. It's a concept car. For dental approaches, earlier they used to take a physical pattern, recreate the mold. Now with the advancements of 3D scanning, you can scan your teeth and 3D print and make the pattern and recreate it. And also make
Yeah.
flexible real world parts and so forth. The kind of a basic approach how CAD to processing, manufacturing, post processing for manufacturing, and end use application goes on. And henceforth, the advantages, one of the advantages is the freedom of design. You can do customization and no tooling requirements like subtractive manufacturing and henceforth. As mentioned, there will be limitations. I won't call it a disadvantage. Such as you have a limited amount of materials compared to the other approaches. And the main drawback in this limitation is the volume in which you can produce parts.
Yeah.
So within the size of the printer restricts the volume of the part. Henceforth, as the volume is restricted, like conventional manufacturing, as the numbers increase, the cost reduces, but in additive, that's not the case. One of the main objectives of additive manufacturing is part consolidation. In a conventional approach, you might be requiring multiple approaches to do things. Like, for example, injection molding of a polymer part, then sheet metal bending and laser cutting, integrating with everything with fasteners. But whereas you come to 3D printing, you can 3D print the whole bottom case in a single metal or polymer part and integrate it with the conventional parts too, which reduces a lot of iterative time and processing time. So let's go forward how things happened. Like earlier, we only had the process where we could cut weld materials. Now there are even CAD software has improved in such a way. It's like topology optimization and generative designs.
Yeah.
These are
AI
not
for it, right?
yeah, or certain algorithms which are more superior than age-old finite element or simulation methods. So these are not kind of possible to manufacture conventionally with subtractive or formative manufacturing. So hence,
Yeah.
additive has opened a new gateway for better engineering opportunities. With
Yes,
these,
I
you
saw
also
a
have a lot.
research paper. A
Yeah.
research paper about it. Like they were designing a car. They had to reduce weight, so they give all the stress and like strength data to the algorithm, and like it did
Yes.
make a similar like design sort of a thing for like
Yeah.
optimized design. Yeah.
So basically, you have the, as you remember, mentioned the load bearing requirements and the load paths. You basically have a rough structure like this. Let's show it up. So you have a raw model which you create, and you add on the loads and the path of the loads onto it. Then
Yeah.
later on, that software algorithm predicts the path of load, and wherever in the particular initially given input model load is not transferring, so it kind of eliminates that material from it. Henceforth, the
Yeah.
final shape in which load transfers is desired with the your desired factor of safety, whichever you have mentioned.
Yeah.
Each technology has its own requirements of design. Similarly, 3D scanning and reverse engineering work alongside with 3D printing in the modern era. 3D scanning can be used for recreating lost data. What I meant to say by lost data is you have a physical part. So, in order to make a physical part, values or dimensions of the part and what are the approaches and materials to be used.
Yeah.
So, for example, there is a company, they have a product which has 1,000 components. Few components are made by that particular company and others might be outsourced to OEMs, original equipment manufacturers, for electronics or basic standard parts. So you have a perfectly running product line and suddenly the OEM has shut down. You can't basically stop your product or redesign the whole product. Instead of that, you take the component of the product which is not having engineering data. So you use a manual reverse engineering if it's a basic product, or a light based or laser based 3D scanning approaches, where you collect the surface data and use it to recreate and make the CAD model, validate it, and again go for production again. That's how the 3D scanning and reverse engineering approach works. So there are also multiple ways of doing 3D scanning of an object, which might be contact or non-contact based.
Yeah. I guess
Basically,
mostly use
yeah,
like the commercial use photogrammetry for it right now.
yeah, this is photogrammetry, which is very
Yeah.
kind of economical and easy to do, and this is mostly done for surveying or hobbyists.
Yeah.
You have laser triangulation method, light and structured light projections, and CMM. This is where a physical probe touches for inspection.
Yeah.
Basically, you have a light source and the cameras to capture it. So the angle and time taken for it to get back to the camera defines the point. So henceforth, multiple points are picked up, physical points, and the scanning is done. And also based upon the field of view is nothing but the area in which your scanner setups can scan. So it's not like you're standing here and in a few feet or a couple of meters there is a part you can directly scan it. So there's actually a certain distance which has to be maintained in order to pick up the surface data. And few of the advantages is like without contact you can do that. So there are very delicate objects, anything like that, or a very flimsy object. If a probe goes and touches it, the object might move or deform. Henceforth, you won't get the exact data. So non-contact based scanning actually gives a
Yeah.
really big advantage for that, and also for high speed accuracy of scanning. And you can also automate this with robotics. So basically, you can scan a model, give it into the CAD software, and finally go for the 3D printing. So this is the scan data. You can use the scan data for later aligning into a CAD software, recreating sketches, and that sketch you can use it to create the reference drawing through which you are actually making the final model and you can inspect it. Like this is the final created model from the 3D scan data, and you can inspect and check what is the deviation for any corrections required. Uh, that's how the approach of reverse engineering works, and these are one of the prominent reverse engineering softwares in the market. This is a basic overview about additive manufacturing and the conclusive technologies which it works with in the industry.
Yeah. I mean, it is so refreshing to learn about these things. Like many
Mm.
people would maybe think this particular PPT was a bit academic for their taste, but I think knowledge can be represented in many ways, and you did in a PPT form.
Okay.
Yeah. So yeah, let's talk about why people mostly choose engineering, and they don't care about their like other specialization in it because they just want to go for IT. So I guess what you did in the mechanical and manufacturing field was meant to be done by most people. So like, what are your comments on this?
Hmm. It's an interesting question. So you have to think about the population, the mindset of the population, and all people are not patient. It took me nearly 5 years to kind of stabilize and get a good paycheck. People might
Yeah.
not be ready for that, but there is job security, and I basically took manufacturing because, as I mentioned earlier, I'm interested in knowing how things work and how things are made.
Okay.
So it's a perspective thing. Apart from a perspective thing, it also might be the upbringing or peer pressure. It's like the whole group is going for engineering. Okay, let's take engineering. Everyone is going for IT. Okay, let's take IT. Most of the people, unfortunately, don't have a vision in life. They basically follow. So that's what most of the crowd is going for the IT. That's how the IT industry actually developed because of it. And finally, it went to such a state where it had a saturation point and it's falling down again. So it's
Yeah.
not like
I guess
basically
it
IT. Yeah,
was
yeah.
Yeah, it was reverse. Basically, IT offered a boom. So that's why there were many like high paychecks, and there are some still now. But seeing that there was a huge like inflow of engineers in IT, and right now
Yes.
like there is more supply and not much demand, and like it is decreasing very very fast with layoff and all. I mean, you know the news.
Yeah, that's also kind of thing I just recollected. Like when I joined my engineering in 2015, my seniors were around 680. When I left the college and returned back after 2 years, the strength of mechanical engineering students was 22. In 6 years, it
Yeah.
went from 680 to 22.
Yeah, I mean
It's all
that's the
because of
whole.
the job market. So now it's again picking up due to the layoffs in the IT industry. But still, it's not like life is not a singular way where you go through education, you get a job and do. You can do multiple things. You
Yeah.
can produce food for the public. You can be a shopkeeper or a reseller or a retailer. Nothing is wrong in it. Basically, we are all doing things for two basic things in order to fulfill our basic necessities and our desires,
Yeah.
or spend our time in a productive way rather than literally exist without a meaning. So I don't think again it's we are talking about skills. So skills are not only like industry skills. There are multiple skills which are required in life for a better uh, livelihood. Financial skills are important. Skills in order to maintain your body health and nutrition are also very important. Basically, communication skills. Many people have many ideas, but they unfortunately are not good at communicating and they're unable to communicate their troubles or ideas. So if we, in a whole, if we concentrate on not only the basic things, but all the necessities as a whole, then only we can actually solve problems.
Yeah.
It's like I'm not saying multitasking. I'm kind of saying as understanding the problem as a whole from multiple perspectives. So that's where you have a deeper understanding of what is required, and so you can plan, set goals, and work on it.
Yeah.
This
I
is
guess
what
what.
basically, yeah,
Yeah. Yeah. You can complete.
yeah. This is what basically people are not doing. So I used to. It's like as I mentioned, I come from a. I cannot say a strict military household, but kind of a decent ex-serviceman, my grandfather. So he made us plan everything, structurize everything. So when I went to, I never was living in hostels till my engineering. So in engineering, I was in a hostel like around 450 kilometers away from home, and it was a nice experience. But I've seen people with different mentalities.
Yeah.
I used to keep everything neat, structurized. Used to plan. There was my roommate who used to throw off everything. Sometimes he used to get serious and he used to scramble off whole my cupboard. They were like, why are you doing that? Some people also, I'm not a OCD guy. I'm just a normal guy. They used to say, you have OCD. You keep your things clean. I like, okay, perspectives differ.
I mean,
You have
OCD
to
does
just,
include anxiety with it. I guess you don't have that with arranging your
hopefully,
stuff.
I don't, I guess. It's a basic
Yeah.
thing. You're taking care of your household activities. Those people, like you have a spectrum of people which think you're in a college life. You have to enjoy it. And literally, you live in your own trash and use your own used up clothes for a couple of weeks. There are certain people who think that's common. There are certain people who think if you're regularly arranging, washing your clothes, planning your stuff in life, you're doing it over. You can't argue on that. Each person has a different perspective and his decisions shape his life and he has to own it.
Yeah.
That's all.
Yeah, that's the thing about perspectives, right? Because they develop based on your upcoming in life and what you have
Opinion,
seen and
yeah,
what you
yeah,
have
basically
like
experience of life.
what you value in things. And I guess what
Yeah.
worked for you was basically you knew in a certain hint like what you wanted to do, and you just pursued it. And it takes really a level of maturity, I guess, for to know that particularly. And many people do lack this maturity, and that's why they can't decide what they want to do in future.
Maybe it can be maturity or it can be the circumstances they are in. For example,
I
let's
mean,
take
yeah,
their,
definitely.
yeah, yeah, basically what you said, maturity is from the circumstances they are. For example, let's take most of the population, they need to decide what they need to do in order to have a livelihood. There might be a certain spectrum where they're well versed, their security of life is taken care by parents or family
Yeah.
fortune. And they don't care about things. It's all different perspectives and different things. You have to go with what your life offers, and it's not like you stay like that. You try to improve yourself. You try to take in multiple perspectives so that you can also learn from it. Take the good in everything.
Yeah, definitely. Because like I have seen many people, if you do ask what they wanna do, they just say like we'll just do the degree and we'll see what to do afterwards.
Yeah.
I like to tell you, basically I did my engineering in IT, and I knew like I had a hint of what I wanted to do, but like the steps were not really defined for me. So for me also, these placements time was really a mess up. I didn't really sit on it, but I had to take some internship to complete my degree. But
Okay.
after the it ended, I realized it was basically an end of a conveyor belt. So I had to like formalize it. So I went on a spiritual journey, and like was outside for like backpacking for the whole month of February this year, and then certain
Oh,
things fell into place, and like I got a trajectory. So right now I'm doing MBA, and hopefully marketing will be my specialization.
yeah, marketing, it's an interesting field. It's very important to sell your product. Maybe I
Yeah,
can
definitely.
find the problem statement and design it and make a wonderful product. But if I don't know how to sell it or market it, I can't do anything with it.
Yeah. And the interesting part is I am a forever science guy. So like school, I was a science person, and like I am still right now, but I did engineering in IT. I do know everything about tech, apart from the coding part, because I don't really enjoy it. And right now I'm doing this particular thing, so that afterwards, if I have to start something of my own, I have all the skills.
Actually, I'm also very interesting how you took podcasting as one of your endeavors of life. It's like you actually can learn a lot in a less period of time
Yeah.
by taking experience of multiple peoples. That was a really nice move.
Yeah, I know. Yeah, you are unlocking my
Yeah.
secrets now. So we can talk about this off camera, so that my secrets aren't revealed. Uh, so there are few things basically. So this skill thing was really a anchor, or like a uh, major phase which influenced your life and got it on track, right?
Yeah. Basically, maybe if I let's speak, I was a normal guy from not a prominent university who's going into the job market. Maybe I think so. I wouldn't have reached this far in this limited amount of 5 years. Apart from kind of, I can say, a unique risk which I took. It took
Yeah,
some time, but the fruits are visible.
yeah. I mean, you have
So
done a lot of things which are mentioned in your LinkedIn, but
yeah,
yeah. So like talking about the exogic labs, we have less time, so we'll go through the overview only. So like how
yeah,
it
sure.
got started, because like why interested me was dark room manufacturing indigenous. So yeah, tell me about it.
Basically, this is a startup by one of a close friend, Dhanush. He's from Tamil Nadu and from a mechatronics background. He's a very sharp and clever dude. So he had a vision like he also done a lot of projects in his manufacturing time during his engineering, and he told he found a issue done manually. So lathe operations, bending, tube fabrication, welding, and all. So you have
Okay.
a certain degree of quality which can be arrived. It all depends upon the interest of the individual who is doing it. Unfortunately, I cannot say all the people involved in the manufacturing industry are fully focused on what they want to do and they do it for getting the best outcome. So,
Okay.
henceforth, he thought this is a big kind of niche which is there, which is not solved by many. Like, why can't we try to automate the process of manufacturing of standardizing the manufacturing process with the help of robotics and AI by teaching it quickly for different approaches. So dark factories are nothing but basically, China. Most of the factories are run by AI and robots. So you
Yeah.
don't have any human intervention apart from initial programming or maintenance. even slowly in the upcoming years, I guess maintenance also will be taken care by the robots itself. So what it essence of dark factories, they are all run by sensor feedback. So there are no humans. So the whole factory is dark in terms of all the lights are switched off in order to save the power too. So that's how things are running in a very sleek manner. It takes some time for doing that. People are also looking into automation solutions in India. That's where Dhanush had this vision and creating
Yeah.
this company. It was founded a year ago, and this is how the journey is going on. And recently we launched our first product, Magician, and this is the launch video by Dhanush. That is Dhanush over there. Yeah, that's
Hey,
Dhanush.
we are
You can
builders
play
as
it.
well, and we know how extremely difficult it is to build real things in this world. Just like you, we've been through these endless phone calls, Excel sheets, and iterations to just get one part right. And the worst part is we've accepted that this is the reality. And we don't want it to be that way. And that's why today we are introducing XLogic.
We are building dark factories for metal fabrication. We had just one goal when we designed these robots that can push out parts not just in high volume but also wide variety of it. Here are the robots we've built so far to automate most processes in sheet and tube metal fabrication. Along with it, we've also built a software for designers and engineers where they can just drag, drop, and get instant quotes for their custom parts along with manufacturability analysis, easily saving over 10 days in pre-production talks.
And we are open for business starting today. Go order your parts at xlogiclabs.com.
Yeah, so what I like about this was basically you guys are, I mean, making the shovels for the gold rush, which is about to happen in the space of manufacturing in India.
Yeah. Also, the best part is, as we are one of the initial players over here, we can collect a lot of data and further have a deep analysis in the market and launch better or highly in demand requirement like problems can be solved, and such products also can be delivered earlier.
Yeah. 1 second, it got hung up a bit. I'll try to edit out this part. Basic, yeah,
Okay.
yeah. It
No,
is cool now.
I was just looking at you when you're speaking it. So
Yeah, sure. I guess the website calls something and my Chrome froze. So yeah, basically, can you describe what is the importance of indigenous manufacturing right now?
yeah, basically, so most of the manufacturing equipment in India come from China or Europe.
Yeah,
So the software is developed by them, the hardware is developed by them, the spares are given by them. So if you want to do some customization, one, there is no option to do that. Two, you have to pay a lot to do that. Three, you want any space, you again have to go to the OEM. You have to import everything. You have to pay a lot of customs duty and GST on that.
yeah,
So when things are developed in-house, the best part is security. So it is locally resourced, it happens locally. You can go speak out things, customize it very easily. Things can be done quicker. The transportation lead time is reduced. Your customs import clearance time, the duties you pay, everything henceforth cuts down. And also then India also can produce high quality economic goods, which the world can actually take in. Because we are currently unable to compete the prices of China, for example. The
yeah,
reason is we are using their resources to make a product and sell it into the market. But henceforth in China, things are automated and they are the OEMs. So it is kind of more economical for them to produce the same thing which we are trying to produce it in India. So if we
yeah,
are having our own machines, our own software, our own system, so it's easy to even resourcing certain raw material. For certain applications, you might require certain certified grades of materials. So certain grades are not available in India. You have to import it from Europe, US, or China. So you take a lot of time. once you receive the sample, you have to cross verify the chemical composition, do some mechanical testing and all that stuff. Unless otherwise all these things are cleared, you can't further proceed with taking a bulk order. So this takes a lot of time. For example, all of these stuff are within your reach, within a few 100 kilometers away, and 2 or 3 days away to get. Like, it's a totally different game changer over here.
Yeah. So are you guys only making the shovels, or like are you also planning to do, like, there is a Chinese company, I guess, PCB way. It makes
Yeah,
all the PCBs also, 3D printing also, all the manufacturing also, and the 3D printing of metals also, I guess. So you looking into it?
we do have a greater vision over here, but since we are in our early budding stages, once we scale up, we'll start up including the other things too. So
Okay,
this is
okay.
one of the niches we found in the market, and we are focusing on this as the current aspect. Once we are stabilized, we'll explore the other areas definitely.
Yeah, I mean, and because these robots are very complex, you would need a very much R&D into it, right?
Yeah.
Yeah, I mean, that is cool. Anything wanna share about Xlogics Labs? Like, how do you feel working in it and all?
This is my first opportunity actually in a startup. I haven't experienced a startup culture before. So the best part about startups is you own the work you do. So it's on your hands. You have to explore the stuff. You have to use your own intuition, your own creativity. As you are the initial founding technical people who are making the problem statement into a reality. For example, in the earlier established companies I worked, I was not having the full freedom to do what I thought about. There was a standard operating procedure in which you have to abide with.
Yeah,
So still we have standards which we use for manufacturing our product, but your thought process and the way you think and the freedom has increased. That's the best part I thought about this startup and the problem statement which they have taken to solve in the real world and how it really helps India in the step of Atmanirbhar Bharat.
yeah. So my last question would be, since you're in the manufacturing space and you do know about 3D printing and all, is it a common ritual outside the creator and you do space to print a benchy in your first 3D printer, like as soon as you get it? If you know what benchy is,
Mm,
the boat.
yeah. 3D Benchy, yeah, the boat which analyzes a lot of print quality aspects.
Yeah. So it is,
So
right?
basically, yeah, kind of, but I can say
Okay.
you can still use that. But nowadays, 3D printing technology has gone further a bit in advanced way where you have automated 3D printers which bed leveling, obstruction
Yeah.
sensors, flow rate analysis, dynamic flow rate stabilization, fine tuning, all are done by the machine's algorithm itself.
Okay.
So
Okay.
earlier, for example, there was a printer, you have to give lot of inputs, do trial and error, fine tune the things. The construction of the 3D printer should be properly aligned together. In order to check that, you
Yeah.
had multiple fine tuning or test prints, in which one of the prominent was the 3D Benchy, the board part. But
Yeah.
nowadays, such as companies like Creality, Bamboo Labs, and all have kind of automated this whole process with their automated 3D printers, where you only have to give your input of the part and the whole algorithm of giving various things like supports, the speeds, flow rates, everything is already preset. You can still fine tune it, but it's fine tuned to the best levels possible.
Yeah.
So
I guess
that's
we
where
can.
they're
Yeah.
cutting the aspect of skill and they're trying to
Yeah.
automate it.
Definitely. Definitely. Yeah, but I still think we should do it as a part of a tradition and maybe an old remnants of past. It would be cool to do it.
Definitely.
Yeah, so this is the end of the this episode. Any comments, questions, or criticism for me or this episode in general?
It's an interesting journey you're going on and taking in perspectives and giving opportunities like this for people like us so that we can also share our perspectives and our thoughts to the world around and for the youth of the world and India, you can also search upon multiple things before like fitting or fixing a particular career. So I guess podcasts or interactions like this give people an opportunity to think out of the box, like to let them know there are also furthermore things or opportunities available in the market.
Yeah, definitely. Any questions for me?
That's all, Yash. And thank you for the opportunity and Namaskar.
Yeah, namaskar. So we'll end it. You can wait in the waiting room and we'll continue.
Sure.